Okay, you are welcome back. Now we come to section 5.5, which is amortization. Amortization. So we are going to discuss in this section of amortization how repayment on loan works. How repayment on loan works. Okay, so all of our regular repayment are the same, and we are working with debt. Okay, we are working with debt, and we always use the present value formula of the annuities. Recall in the previous videos, please, if you have not watched that video, you need to watch that video. So we have what we call ordinary annuity. Ordinary annuity, which is this formula. And then we have what we call annuity due. Annuity due, which is this formula. Okay, in ordinary annuity, this is payment at the end. In annuity due, this is payment at the beginning. Okay, so when you see in a question at the beginning, the payment is made at the beginning or in advance, that is annuity due. But when the payment is made at the end, or there's no indication of the beginning in the question, use ordinary annuity. Use ordinary annuity. Okay, so we are going to be using any of this formula to calculate the payment first. To calculate our payment first in amortization. Okay, so for example, if we buy a house of 1 million on debt by getting a loan from Bank Z, while we are living in our house, we have to pay the loan back monthly at 10% per year, compounded monthly for 30 years. Okay, from this given example, we have our debt, the debt of the loan we collected from a bank, which is 1 million. We have our rate, 10%. We have compounded monthly, which is M equals to 12. And then the period we are going to pay for that, which is N equals to 30. So if you look at the question, we're not told that the payment is made at the beginning. Because of that, in order to calculate our R, we use ordinary annuity. In order to calculate for our R, we use ordinary annuity formula. We use ordinary annuity formula to calculate for our R. Okay, so in our calculation, we have the ordinary annuity formula. We have the ordinary annuity formula. Our A is our loan. We are calculating for R. Our small r, which is the rate, is 0.1. We are dividing. Actually, the right formula to use is this one. Divided by M minus M multiplied by N all over R divided by M. So that is the right formula to use, okay? Because we are compounding monthly. So M is not 1. So that is the right formula. So if you use that formula, you use this formula and substitute it inside just like this one, we are going to be getting our monthly payment to be these. These are our monthly payment. So hence, we have to pay back this monthly. All right. We have used the ordinary annuity formula because the question or the example did not indicate that it's at the beginning or in advance. Okay. Now, take note of this. This money we are paying monthly can you see that this amount consists of 2 components, okay, which will be seen later. You will see it clearly later. Number one component is that it contains the repayment of the original principal loan, the repayment of it. And then number two, it contains interest. Okay, the bank charges interest or takes interest. Okay, so we have the payment of the debt we have from the bank. We also have the interest payment. So that money contains that. So the money we paid every month contains these two components. These two components. Okay, so I want you to take note, or we like to take note that number one, a very interesting remark we will see later on is that in the first few payments, the principal repaid is very small. The principal repaid is very small, and the interest is very large. Okay. Now, towards the end, the situation changes, and the principal repay becomes very large, and the interest component becomes very small towards the end. Please take note of that. And then the third one, of course, this is due to the fact that in the beginning we hold a large amount of money, while towards the end we hold a smaller amount as we have made payment in between. Okay, you are going to see that as we take some examples. Okay. So the tool we use to find this schedule or to outline this schedule is what we call the amortization schedule, and it's a table. Amortization schedule is a table that summarizes these four things. Number one is a table that tells us the repayments made at each period. The repayment made at each period. Number two, the principal outstanding on the original loan. The principal outstanding on the original loan at each period. And then number three, the interest component within each repayment. And then number four, the principal repaid. The principal repaid. The principal repaid, that is the money we have paid. This is the money outstanding. Number two is the money we are yet to pay. Number four is what we have paid. Okay, of course, we can include the periods. The period, because we need the period. Then it contains the period also. The periods. So in amortization schedule, we have the period, we have the repayment made at each period, we have the principal outstanding, we have the interest component, we have the principal repaid. Okay, please take note of that. Okay, so this is the amortization schedule, and this is how it looks like. The first column is the period, Okay, now the second one is the principal outstanding, At the beginning, take note of this, at the beginning of the period. Okay. Now this third column is the interest per period. The fourth column is the payment we made at the end of the period. Okay, the payment at the end of the period. And the fifth one is the principal repaid, how much we have paid at each period. Okay, so if we sum up everything you get here, you are supposed to get your loan back. You are supposed to get how much you are supposed to have paid the money you own. Okay, so the total of these is what we call NR. Okay, and then by the time we subtract that from the money we loan, we are supposed to be getting the total interest. So this gives us the total interest. The total interest is NR minus A. That is the total interest. That is number of years we are using to pay, and the payment R, then minus the money we borrowed. Okay, that will be the total interest. Okay, all right. So in this schedule, let me take this again so that I can explain. We are starting with the money we borrowed. And then in the first period, maybe the first month or the first year, we have the interest multiplied by the debt. Okay, that is the interest in the first year. And then we have the payment we must pay in the first month. Actually, that payment is the payment we are going to be making every month or every year until we finish payment, okay? I'm going to explain this later. So now the principal repaid is the payment we made minus the interest for that period. That would be the principal repaid. That would be the principal repaid. Okay, in order to calculate the principal outstanding for the second period, we take away whatever we get here from the initial one, from the initial debt. That will be the principal outstanding at the beginning of the second one. And then we continue like that, till the last one. Okay, at the last one, let's assume this is the last one. Let's call this one 10. Okay, let's call this one 10. Okay, whatever you get here in our ninth one, don't forget this is 10. To get the principal outstanding here, it will be what we have previously in the ninth one. Let me say, okay, P09. Okay, P09 minus what we have here, which is PR9. Okay, minus PR9. P09, which is this, minus PR9. That's what we are going to get here. And then we calculate our interest of that. So we calculate our interest of R. Let's call that one RR. Now, in order to find, because in the last one, the decimal places in the last one is different from the previous one. So in order to calculate this one, whatever you get in your principal outstanding here is exactly what will be here. Okay, it's exactly what will be here. It's exactly what will be here. Okay, don't forget we have this. This is exactly what will be here. We have our RR. So in order to find this, you add this one to this one. Okay. So now, in order to get what will be here, I must add PR9 minus PR9, PO9, plus our R. Okay, that is what you are going to get from that is what will give you what is here for the last one. That is what will give you what is here for the last one. Okay, so the decimal on this one is different from the decimal on the other one. So please take note of that. Okay, so let's use this as an example to demonstrate that. Let's use this as an example to demonstrate that. Okay, so in this one, suppose that a bank lends a borrower $1,500 and charges interest at a nominal rate of this compounded monthly. Okay, the $1,500 plus interest is to be repaid by equal payment of R dollars at the end of each month for 3 months. Here our N is 3. We are not multiplied by anything because they just gave us 3 months. Okay. Now, our R is 12%. Our M, because we are compounding monthly, is 12. Our M is 12. Okay, our loan, which is our A or P, is 1,500. Okay, here are we supposed to use ordinary annuity or annuity due is ordinary annuity. Okay, we are not told at the beginning or we are not told in advance. So we use ordinary annuity. So we use your ordinary annuity formula. Use the ordinary annuity formula, which is A equals to R 1 minus 1 plus r minus n all over r. Please write your formula first. Write your formula first. Okay, so if you put the values there, we are going to be having that. We are looking for r. So I can make r the subject, but let me write everything there first before I make r the subject. 1 plus, okay. Now, because it's compounded monthly, we are supposed to divide by m, but we are not multiplying this by m. Why? Because they say it's 3 months. They didn't say 1 year. If it is 1 year, then we are going to multiply that by 12. Okay, but because it's 3 months, so we just use the value straight. Okay, so we have 12% divided by 12, then minus 3 all over 12% divided by 12. Okay, so that is what we have there. Okay, so you can press your calculator and make sure that you are able to get. So I make this the subject of the formula first. Let me make r the subject. Then I will have this equals to 1,500 divided by the whole of that one. So that will be 1% will be 0.01 minus 3 all over 0.01. Okay. Okay. So by the time you do that and press your calculator, you should be getting something like this. Okay. So that is our payment we are going to be making every month. Every month. Now we want to do amortization schedule for that. Amortization. Want to do amortization schedule for the 3 months. Okay. Want to do amortization schedule for the 3 months. So we have our period. Period is 1, 2, 3. We are just doing for 3 months. Okay. Then we have principal outstanding. Principal outstanding. The money we are yet to pay. We have the interest. Okay. Then we have also the payment. Yeah, the payment. And then we have the principal repaid. Principal repaid. Okay, so when you calculate your payment, this payment is everything. You can just populate this first. This payment, you continue to pay that payment until the last one. Okay, so this last one, you leave it blank because we need to calculate that. We need to calculate that. So you leave it blank. Okay, we are starting with 1,500. So here we multiply our 1,500 by our rate. Now don't forget our rate is divided by 12. So you need to multiply it by 12% by 0.01. That means 12% divided by 12. Okay, so we multiply this by our rate. We are going to be getting 15 if you multiply 1,500 times 0.01. Okay. Now the principal repaid will be this one minus 15. This minus 15. And that will give us 495,03. Okay, that is for the first period. That is for the first period. Now, in order to get for the second period, this 1,500 minus what is here? And that will give us 1,004,97. Okay, that is for the second period. Now, in this second period, we also multiply it by our rate by 0.01. And then you are going to be getting 10.5. Okay. All right, this payment remains with payment. Then in order to find the principal repaid, you also subtract this from this one. Then you get our 98. Okay. Now don't forget, now we are not doing the third one, but in our case, this third one is the last one. So in order to find what is here, you say this minus this one. Okay, that will give us 504.99. That is, and I did explain to you before that whatever, if it is the last one, whatever you get there is exact what will be here for the last one. Whatever you get there is exact what will be there. Okay, now we need to find our rate here. Our rate here, we multiply this by 0.01. You are supposed to be getting 5.05. Okay. Now, how do we get this one? Okay. To get this one, you must add this one with this one. Okay. You add that together, and then you get this one. And that will give us 0.04. You see, this has a decimal different from this. In most cases, this has a different decimal. The last one has a different decimal than the other one. Okay, so that is our amortization table. If you try to sum up the whole of this, if you try to sum up this, then you are going to be getting, if you try to sum up this, if you sum this up, then you are going to be getting our 1,500, the money we hold in the first place. Then we are going to be getting this for this one. Okay, so this is the money we hold and the interest that has been taken from us. And if you sum this will now be the total interest, Okay, so this is now the sum. All the money we have paid include the interest and the money we owe. Okay, it includes that. Please ensure that you understand. So you are going to be drawing this amortization schedule, especially for a fewer payment, maybe up to 5 or 6 or 7 or 10. But if there are more than that, then we can use the formula to calculate each of these items, which we are going to see in the next video. All right, please make sure that you understand.